Here is part of a train timetable. How long does the first train from Edinburgh take to travel to Inverness? So with timetables, we need to remember that each column will be a different train. So we need to find the first train from Edinburgh. This train here doesn't stop at Edinburgh, but the first train leaves Edinburgh at 9:35. We want to know how long it takes to travel to Inverness, and this train gets to Inverness at 13:10 or 1:10 in the afternoon. So we need to find the difference between these times. On a timeline, if we start at 9:35, so when the train leaves Edinburgh, we can add an hour to get to 10:35, then another hour takes us to 11:35, and another hour takes us to 12:35. Now, one more hour would take us to 13:35, but we only need to get to 13:10. So instead, let's think how many more minutes to get to the next hour. Well, if we count on 25 minutes, that takes us to 1 o'clock in the afternoon, because there are 60 minutes in an hour, and 35 plus 25 is 60. And then to get to 1:10 or 13:10, we just need another 10 minutes. So altogether, that's 3 hours, and then 25 plus 10 is 35 minutes. So the first train takes 3 hours, 35 minutes. Now, Ellen is at Glasgow station at 1:30 p.m. She wants to travel to Perth. She catches the next train. At what time will she arrive in Perth? So in this timetable, we have 24-hour clock times, but here we have PM. So to change PM to 24-hour times, we can add 12. So she gets to Glasgow station at 13:30. So this train here, which leaves at 13:15, will be too early. She'll need to get the next train after 13:30, so that's the one that leaves at 13:45. At what time will she arrive in Perth? Well, we can go across from Perth, and we can see that this train gets to Perth at 15:15, or at 3:15 p.m. Look at each of these diagrams. On each one, put a tick if it is the net of a square-based pyramid, put a cross if it is not. So for this diagram here, we have our square base, and then these sides here will fold up. This face will be able to fold around to meet this edge, and then this face here will fold around to meet this edge. So here we have this point, and this point will join and be the top vertex of our pyramid, so we have the net of a square-based pyramid. Now let's look at this diagram here. This square is our base, and this face can fold up. This face here can fold around to meet this edge, and then remember, if this face is folding up, then this face here could fold around and meet this edge. But we can't have any face meeting this edge here. There's no way to get this face over here, so this is not the net of a square-based pyramid. And now we have this diagram here. So this face and this face will fold up. This face here will be able to fold around to meet this edge, and this face here will fold around to meet this edge. Then this will go to the top and be the top vertex or point of our pyramid, and this point here will meet it, so we have the net of a square-based pyramid. This shape is 3/4 of a circle. How many degrees is angle X? So here we need to remember that angles around a point add up to 360 degrees, or that a whole turn is 360 degrees. So because it's 3/4 of a circle, we need to find 3/4 of 360. That's 270. because 360 divided by 4 is 90, times 3 is 270. So that's the size of angle X. The other way would be to spot that if angle X is 3/4 of a turn, we have 1/4 of a turn here, and 1/4 of a turn is 90 degrees. So if we subtract 90 degrees from 360, because 360 is the total of angles around a point, again we get 270. Complete the table. So this first shape has been completed for us. So because it's a triangle, they've put a cross under 4 sides only. They've put a tick under 1 or more right angles because it has a right angle in this corner here. Remember, a right angle is like the corner of a piece of paper. They've put a cross under 2 pairs of parallel sides because remember, parallel sides or parallel lines are lines that would go on forever without ever crossing if we extended them, and a triangle can never have parallel sides. So let's look at this rectangle. It has 4 sides and it has 1 or more right angles. With a rectangle, we have 4 right angles. It also has 2 pairs of parallel sides, because the top and bottom lines, if we extended them, would go on forever without ever crossing. So remember, parallel sides are like train tracks. And we have 2 pairs, because this line here and this line here would also, if we extended them, go on forever without ever crossing. Now let's look at this shape here. Here we have a shape with 1, 2, 3, 4, 5 sides, so that's a pentagon. So we need to put a cross in this box because it doesn't have 4 sides only. It does have 1 or more right angles because we have 2 right angles in this shape, 1 in the top left and 1 here in the bottom left. So now we need to think, does this shape have 2 pairs of parallel sides? Well, we can see that the top line and the bottom line are parallel, but though we have 2 lines that are parallel, that counts as only 1 pair of parallel sides. We can see that there's nothing that's parallel to this line here or to these lines, so this shape does not have 2 pairs of parallel sides. It has 2 lines that are parallel, but that only makes 1 pair. Look at these numbers written in Roman numerals. 1 is not written correctly, put a cross on it. So we have Roman numerals which all use the letters M and C. So we need to remember that M represents 1000 and C 100. So in this first number we have MMCM. So MM stands for 2000, and then we have C before M, so that's 100 before 1000, so CM is how we write 900. So this number here is 2900. MM is 2000, and then CM is 900 because that's 100 before 1000. Now we have MCMM. So M is 1000, and then C before M is 100 before 1000, so CM is 900. But then we have another M, and M stands for 1000, but this M, if we wanted to show 1000, would need to be written before the letters that show hundreds. So the cross goes on this number here. But just to check, let's have a look at these other numbers as well. MMMC, so that's 3 M's, so 3000, and C is 100, so we have 3100. Now MMCC is 2200 because MM is 2000 and CC is 200. And finally, MCCC is 1300 because M is 1000 and then CCC is 300. A shop sells fruit. Chen buys 2 apples and 3 bananas. He pays £2.35. Megan buys 2 apples and 1 banana. She pays £1.25. How much does 1 banana cost? So we can see that Chen buys 2 more bananas than Megan and buys the same number of apples. So if we find the difference in what they pay, that will give us the cost of 2 bananas. So we can work out £2.35 minus £1.25. That's £1.10. So Chen pays £1.10 more, and for that he gets 2 extra bananas. But we want to know the cost of 1 banana. Because we know the cost of 2 bananas, that's £1.10. To find the cost of 1 banana, we can divide £1.10 by 2. To do that, we can use short division, and that gives us £0.55, so 55 pence as the cost of a banana. The line on the grid is one side of a square. On the grid, draw the other 3 sides of the square. So one way to do this, which might make it easier, is for us just to turn our page to make this line either horizontal or vertical. Or we could use a different method. If we look to get from this point, so this will be one corner, to the other corner that's shown for us, we go across 2 and up 1. So if we go down 2 and across 1, we know that this will be our other corner, and then again we can go across 2 and up 1, so this will be the last corner, and then we can just join up our points, and we have a square because we have sides that are the same length, and all of our angles are right angles. Look at the shape drawn on the square grid. For each of the 4 sentences below, put a tick if it is true, put a cross if it is not true. First, we have the statement, the shape has exactly 2 right angles. So remember, a right angle is like the corner of a piece of paper or the corner of this screen. And we have a right angle here and a right angle here. This angle is larger than a right angle, so that's obtuse, and this angle here is smaller than a right angle, so that's an acute angle. But we can see that we do have exactly 2 right angles. Now the shape has 2 pairs of parallel lines. Remember, parallel lines are like train tracks. They would go on forever if we extended them without ever crossing. So this line here and this line here are parallel to each other, but our other 2 lines are not parallel, because if we extended them, they would eventually cross. So this is not true because our shape only has 1 pair of parallel lines. Remember, if 2 lines are parallel, that counts as 1 pair. Now, the shape has 1 line of symmetry. A line of symmetry is where you can draw a line down the middle of the shape so that you have the same reflected on both sides. But this shape we have here is not symmetrical. And finally, the shape is a quadrilateral. That's true because it's a 4-sided shape, and quadrilateral is what we call any 4-sided shape, because quad means 4. Circle the 2 prime numbers. So remember, a prime number only has 2 factors. It's only in the 1 times table and its own times table. So 29 is a prime number because that's only in the 1 times table and the 29 times table, not in any other times tables. But 39 is not a prime number. That's because 39 is in the 3 times table. We can see that if we divide 39 by 3, we get 13. So because we don't get a remainder, we know that 39 is a multiple of 3. And we also know from this that it's in the 13 times table as well. So the factors of 39 are not just 1 and 39, but also 3 and 13. So that's not a prime number, it's a composite number. 49 is a composite number as well, because 7 times 7 is 49, or 49 divided by 7 is 7, so a number without a remainder. So the factors of 49 are not just 1 and 49, but also 7. 59 is our other prime number, because that's only in the 1 times table and the 59 times table. 69 is a composite number, because if we divide 69 by 3, we can see that it's in the 3 times table. 23 times 3 is 69, so 23 and 3 are also factors of 69, and a prime number is a number with only 2 factors. 69 is in the 1 and 69 times tables, but also, as we've shown here, in the 3 and 23 times tables. Circle the fractions that are equal to 60%. So a percentage is a fraction with a denominator of 100. Now none of the fractions we're given have a denominator of 100, but remember, we can find equivalent fractions, and if the fraction is equivalent to 60 hundredths, then it will be equal to 60%. So 60 and 100 are both in the 10 times table. So if we divide both the numerator and the denominator by 10, we get 6 tenths. So 6 tenths is the same as 60%, because it's equivalent to 60 hundredths. But we could simplify this fraction further. If we divide both the numerator and denominator by 2, we get 3/5, so that's equivalent or equal to 60% as well. Now remember, 60 hundredths is the same as 6 tenths, but some of our fractions have a denominator of 60. We can't get 60 from 100, but when we simplified it, because we got 6 tenths, we can change tenths into 60ths. 10 times 6 is 60, and 6 times 6 is 36. So 36 over 60 is equal to 60% as well. Because 60 hundredths is the same as 6 tenths, and 6 tenths is the same as 36 over 60, we know that this fraction must be equal as well. We also have other fractions with a denominator of 60, but because we know that if the denominator is 60, the numerator is 36, we don't want to circle this fraction or this fraction. So then the other one that we've not looked at is 6/20ths. That's not going to be equal to 60%, because 60% is more than half, but 6/20ths is clearly less than half, because remember, half would be 10/20ths, and 6 is less than 10. 6 is less than half of 20, so we don't want to circle this fraction either. We need to circle 3/5, 6 tenths, and 36 over 60.